What's the next thing that we intend to do? We also intend to generate the statistical models advanced output. Now, when we speak of statistical models advanced output, what is that supposed to mean? Let's click on output. Now, we can select any of these values here or any of the nodes here to generate some kind of meaningful output. So let us select transform. Well, let's have it this way. If I run, right, click on this and I click run from here, no fields have been specified. Of course, we have not. So click on transform, click on edit. Now we understand it better, right? That we have to define the attributes and parameters in and across the nodes, irrespective of, I mean, without that, it is not going to work. Meaning there has to be some field which has to be identified for any stream to run. So then I'm selecting aspect ratio over here and I click apply and I click OK. And, what are the options? Selected formula. We are leaving everything as is. Click apply and I click OK. So we can see it's showing us one field. So right click on this and let's scroll down and select run from here. Right. So what do we see here? For aspect ratio, these are the outputs that have been generated, the transform outputs that have been generated. Now that's select a transformation, current distribution, inverse, log normal, and log 10, exponential, square root. So let's open square root, any random output that we can. So what do we see here? The aspect ratio that we are seeing here is 1.3887, count of 897. So that is the histogram of the aspect ratio square root. If we take the exponential value of that, yeah, that is 6.07 e raised to minus 30, and the count is what 897. So these are the different expense ratio values that we are seeing for these distributions, and that is evident over here, and that is the output that is getting generated. Fine, so let's come and save this. Transform our distributions. Now, the interpretive part is I'm leaving it for you all to work upon. If you click on inverse, so out here we can see there is perfect normal distribution type structure, the bell shape, but it is fine. That is how your graph is showing up here. Yes, if you want to split in bands, that is also possible. If you don't want to split in band, that is also there. So split in bands are formed with 3 equals. Let's click on split. Yes, so we are seeing first, second, and the third band. So in the third band, we are seeing that the bell shape is peaking at the third band. And its aspect ratio, no aspect ratio is 0.6516. Then increase the split. I click split. So there'll be 8 bands out here. 1, 2, 3, 4, 5, 6, 7, 8. So again, what is the significance of these bands? Well, they help us in working on particular band or particular section in that band. So this is how it is. And I click OK. So that is the output that we generated by using the modeling nodes. So I click OK. I'm closing. Yeah, I click OK here. And this is now completed. So this is how we conduct the modeling outputs analysis. We are yet to work on the neural networks aspect of that. So let us do one thing. Let us check out the data sets that we have. Let's check on statue images, data set features. If this we have very healthy count of values whereby we can, okay, that's the Kirmizi pistachio, that is a class of pistachio. We don't need the shape factor, so I can delete it. What more do I need? Area parameter minor, yeah, area minor. I click delete it. Can we have PDIS Q? No, I don't need that either. I'm retaining solidity. Extent and yes. So fine. Now 1, 2, 3, 4, 5, 6. 6 of these are your variables, and I'm saving this as live session. Today's day 8. Fine, let's save it over here. We are saving it as an Excel file. Hopefully this is an Excel file. If not, let's check it again. Yeah, it's an Excel open file. So I click save, place it. Yes, I'm closing this window. Let's go back to the software, and I'll open another stream here, which will be for Kirmisi Pistachio. So let's click on another stream here, and I'm renaming the stream as what? Save as, yeah, that is your file stream name. I click save, and so now that is set. Now let us work on the neural networks aspect. So again, I'll go to the source. I click on Excel, right click, I scroll down and click on, okay, you scroll up and click on edit. I'll import the file here by clicking on these 3 buttons here. And we have the pistachio data set. I click open. What are the filters? We are not taking any filters as such. So let's retain all of them. Types, yes, we are having, let us read the values. Let us have the default reading by the SPSS Modeler itself to avoid any errors. And refresh it. Yes. I click apply, and then I come here and I click on OK. Fine. So with this pistachio Excel data set, we'll now associate the modeling node. That is the modeling node. We are selecting supervised node only, of course. There is nothing on the association nodes that we can take on the segmentation, although we can take 2-step AS segmentation. We'll see in a later part of this session if you can pick one of these 2-step AS. Okay, means AS segmentation. Meanwhile, sticking on supervised, let us click on neural network. So that is the node that we have selected. Now out here you can see there is no targets again. So unless you select a target in a modeling node, it will always show you that there are no targets. So fine, right click on that, click on edit, and use custom field assignments. Yes. Now, what do you want to really study about? I want to study about the aspect ratio. So I'm setting that as a target, and I'm selecting the rest of them: eccentricity, solidity, roundness, compactness, and extent as predictors. Apply. Let's check on the build options. We are building a new model, of course. And then what is the main objective? Is to create a standard model. So that is the honest main objective. I click on basics. That's a multi-layer perceptron. Can we select a radial basis function? No, I'm not going on all that. I'm sticking with multi-layer perceptron. Stopping rules, minutes is maximum programming time. Training time is what they are putting 15 minutes. Now let's see if it's going to last 15 minutes. Customize the number of maximum training cycle, minimum accuracy, symbols, voting mean. And then you click on advanced. So overfill prevention set is about 30%. Now, these are the default settings that these people have, that the software has. So we are going to stick with them. What are the model options? Well, we'll be calculating the predictor importance. That is important. That is important. And once we have the output, then I'll explain why is it important. Automatic and the custom model name. We are selecting the automatic name. Probability of the predicted value. Increase in probability from next to most likely value. So fine. We are setting these as the defaults. I click apply. I click OK. So yeah, as you can see here, from no targets, we now have aspect ratio as the desired target. Now, since this is a modeling node, if we try to run this, most likely it might throw an error that You do not have an output node. So let us not be worried of that for now. I just want to click on the statue and I click run from here. Yes, now it's running. Now see, we can see here that there is a model nugget generated. It is not throwing any error. Why? Because a modeling node will generate a model nugget. But when it comes to eventually the output in terms of table or matrix analysis or the whole bunch of outputs that they are generating, we will need to have an output node to the nugget at least. So fine, let us right click on nugget and see what it has to offer. See, what do we see here? This is interesting. Out here, we can see, yes, now that's the window. We see the model summary. It is a multi-layer perceptron. That is something that we have selected. Stopping rule error cannot be further decreased. Hidden layer, 1 neuron. How many hidden layers are there? 2. Fine, so let's come here and see it. Yes, see, there are two neurons. Okay, 1, 2, 3, 4, 5, 6. And there are 2 neurons. So hidden layers are 2. Again, there are only 2 hidden layers, meaning it's not 2 by 2 or 2 by 3 types. And then there is a bias that is added. And then it eventually culminates into the aspect ratio. This is the extent. If you want to click on top bottom approach, there. If you click on bottoms top approach, there it is. Effects what? These are stylist effects. If you want, we can add the coefficients also. I would rather prefer coefficients, but the values are not showing up over here. And let's have it this way. Oops. So negative to positive. So we can see eccentricity is highly negative, and then the element of bias is highly positive, followed by the bias and neuron true over here. The rest of them are reasonable values in terms of the coefficient cell sign. And let's click on preview. So that is the output, not output, that is the data set content that they are showing us. We don't need it anyway, so I'm clicking OK. Then I click on generate. What can we do here? Well, we can generate a modeling node, we can model a palette. Field selections are also possible. Right, so this was only the first part of this. The next part is the model. That was only the model summary. That is a predictive model. So that's what the thing is here. See, we see eccentricity at 0.81, compactness at 0.15, solidity, roundness, and extent. Extent is like hardly any relevance because its importance is 0. If I come back here or on this node, what do we see? Eccentricity has the highest synaptic weight estimate. I mean, on the negative side, it's minus 0.7. That is what we are seeing here also, that this predictor has greater importance compared to compactness, solidity, roundness, and extent. Again, if I come back here and see it for compactness, solidity, and roundness, these are like, in terms of synaptic weight estimate, they are in between types. They are neither highly negative or they are neither highly positive. So those values, the level of positivity or negativity will be applicable or available in the predictive importance page. That is 0.15 and 0.03, and roundness is how much? 0, and extent is also negative. No, that is also a 0. And this is what? This is the predicted value that is observed. So we can see there is upward trend out here on the predicted value, and equally on the aspect ratio. So this is how your model nugget or the model for the neural network is generated. But that's not an end in itself. Let's click apply and I click OK. Now, after this is generated, let us go to the output modes and see what more can be done about it. So let us select the analysis of here and see how will this node react with the model nugget. Right click and I click view data, click run. Yes, now what is that? That is the analysis that it generated. So comparing neural network aspect ratio with aspect ratio, the minimum error is this, maximum error is this. These are the different outputs that are generated, results for the output field for aspect ratio. Let's save this. This is interesting. So that is the output. That is the report that has been generated. What more do we have here? Annotations, nothing. Click on edit file. It's much the same. You can export this as an XPS, HTML, or a text format. So what do we see here? The mean absolute error, MAE is 0.006, mean error is 0, standard deviation is 0.01. So it's relatively stable at only 1% variability. And then we have the linear correlation at 0.99. So that's 100% correlation. Occurrences are 2148. So 2148 means what? Those are the number of counts that are available. So all number of observations, N as we call it. I click OK. I'm saving the stream, of course. So in outputs, we have selected what different histograms and the analysis.